Assalamu alaikum and hi. The title of this invention is Integrating Industrial Internet of Things, IIoT, into the Classroom. A hands-on approach using Siemens S7 1500, IoT 2050 and Factory I/O technology. The integration of Industrial Internet of Things, IIoT, technologies into educational curricula is essential to bridging the gap between academic learning and industry requirements. This project explores a hands-on approach to IIoT education using Siemens S7 1500 PLC, IoT 2050, HMI, SCADA, Ubidots Cloud Platform, and Factory I/O. Figure 1 illustrates a typical IoT course setup in higher education institutions, highlighting the current academic approach to IoT practice. However, the technologies and tools used in academic environments often do not align with the advanced systems utilized in industries, leading to a disconnect between classroom learning and real-world industrial applications. This project seeks to bridge this gap by integrating IIoT into the educational curriculum using industry-standard technologies, including Siemens TIA Portal, Simatic S7 1500 PLC, HMI, SCADA, IoT 2050, Ubidots Cloud Platform, and Factory I/O. Refer to Figure 2, an industrial IIoT setup incorporates standardized communication protocols, seamless system integration, and efficient data processing to create a fully functional automation ecosystem. The integration of IIoT into the academic curriculum has significantly enhanced students' employability, as reflected in the employment data of graduates across multiple batches. The cumulative data from 4 batches shows that out of 77 graduates, 55 graduates or 71.4% secured jobs in automation-related industries, while 22 graduates or 28.6% were employed in other electronics-related fields. Breaking down the data by batch, the first batch had 21 graduates, with 16 employed in automation-related jobs and 5 in other electronics-related fields. The second batch consisted of 16 graduates, where 7 entered automation-related careers, while 9 pursued roles in other electronics fields. In the third batch, the highest number of graduates was recorded at 28, with 20 securing automation-related positions and 8 employed in other electronics fields. Finally, the fourth batch had 12 graduates, all of whom were successfully placed in automation-related jobs, demonstrating a strong alignment between IIoT training and industry demands. These figures highlight the effectiveness of integrating IIoT technologies, hands-on learning, and industry certifications into education. The data suggests a growing demand for automation professionals, with more graduates transitioning into IIoT-based roles over time. Additionally, the absence of non-automation placements in the fourth batch indicates an increasing preference for IIoT-driven careers among students. This trend reinforces the importance of bridging the industry-academia gap through practical IIoT training, ensuring students gain relevant skills that enhance their job prospects in the evolving industrial landscape.
So this is a simple coffee machine. So in this example, our system, we are trying to control 3 tanks, which represent espresso, milk, and foam milk. Together, it can form 3 types of coffee, which is espresso, latte, and cappuccino. So here, the system, we program the PLC to control all the 3 tanks. Based on the recipe that we set on the HMI.
So you have
PLC.
So
we have PLC, we have HMI. So this system can be controlled by HMI and also physically on the PLC by using the Factory I/O. Okay, so we have the physical button here. There are 3 buttons to fill up the 3 tank and also 1 button to make a coffee, to start making a coffee.
Okay.
Plus here also we are utilizing the IoT 2050, which is the Siemens IIoT as a gateway to control our system through cloud. So for the cloud system, we are using the Ubidot dashboard cloud system. So in real time, you can see that the HMI and both the HMI and the cloud dashboard sync real time. Okay, so let's start making coffee. So for example here, the user can choose what type of coffee they want to make, and each type of the coffee have the different combination of 3 tank, espresso, milk and foam milk. So for example, now we are doing the let's select a different one, a cappuccino. Okay, so we send it to the PLC. Okay, and let's start making coffee. So for example, now we are using the HMI to start making coffee. So the tank start to dispense the coffee the coffee and milk based on the recipe.
Oh.
Okay, and when it's done, the conveyor and the box represent that the coffee been delivered out
Okay.
it's been done. Okay, so if you can see here, the water level inside the tank tally with the real tank we have on the factory IO. And also the advantage of this system is we connect the system with the IoT. We can monitor the water level. The water level inside the tank from the factory from the HMI. We can also view it, monitor it remotely using the cloud dashboard. So this is the real data, and for example here we can start making coffee also by utilizing this button from this dashboard. So when I click, so see the water start being dispensed from the tank. And our coffee is done. And we can also fill up back the tank by using this remotely, by using the cloud-based dashboard. When I push this button, each of this tank is start filling up.
Okay, so start to fill. Okay.
So actually the level meter here is based on the factory IO spec. Actually, when it's empty is 0 volt, and when it's full is 10 volt. So that's why the value is from 0 to 10 volt. So 9.99 is considered 10. Okay, that's all. Thank you.
Okay, thank you.